Hello, Anna and Lorena. How are
Hey,
you
Professor, how are you feeling?
guys? I've been doing all kinds of stupid stuff because I'm bored at home. And so I got in trouble cleaning my garage. It looks like I got into a fight, doesn't it?
Yeah, I hope you're okay though.
Yeah, it's whatchamacallit. The people who looked at my eye said that it was just an eye infection from who knows what cleaning my garage. So it was not a good idea to clean my garage.
Wait, how's Dora?
Oh, she's a sweetheart. She's good.
Aw, that's cute.
Touching me all over.
Maybe if she gives it like a little kiss or like it'll feel better.
So I'm gonna send you some things right now via the chat. I'm sending you some links. And the links are titled in the chat. Yesterday, I sent you a bunch of files that had solved out problems from exam 4 module from chapters 9, 10, and 11. And so I'll take any questions that you guys would like me to cover on any of the exam 4 module questions. So if you just want to order them, thank you, Anna. So I'm going to start with some Lab 10 questions that Anna put up on the chat stream here. And then some Lorena questions from chapter 11. And then, as I mentioned before, we're covering through exam 4 module, and we were going to bypass exam 5 module. So the exam 5 module is not something that we'll have time to cover. That's what chapter 12 is about. If you want to work through chapter 14, which is lab 12, quiz 12, and exam 5, those points can be applicable to your grade as extra credit points as well, but they're not going to be necessary for you to complete the course. It's through exam 4 that will complete the course. And if you have questions about the exam 5 module, I'll reserve those for the afternoon, for our 1:30 p.m. to 4:30 p.m. today, tomorrow, or Thursday. Is anybody graduating this semester with us? Any one of you graduating with us? Okay. I was going to wish you a happy graduation either way. So let's get started with Anna's request of Lab 10 questions, and then with Lorena's request of Chapter 11, okay? If you still wish to turn in the Chapter 8 extra credit, please do so. That'll be a good thing. Though you can just send it to my email, to alacayo@dvc.edu. Okay, so let's get started by going to Lab 10 in your class section. So it's questions 3, 6, and 7. Okay. There we go. So in chapter 10, the focus of chapter 10 is this slide that you see up on this screen. The name of the file is in the top center. Chapter 10, exam 4 questions using hypothesis testing for proportions. Hypothesis testing in statistics is the application of something we call deduction or deductive reasoning. Deductive reasoning is when you learn by taking away, the lesson you take away from an activity. In this case, the activity is a process that takes you from the blue to the red to the purple in our screen. By the blue, I mean, notice how there are 4 blue boxes, 4 blue areas. And then notice how in the red activities, what we're doing is reducing the blue areas into red areas. So we start with 4 parts to a hypothesis test that gets reduced to 3, then to 2, and then ultimately just to the purple box, which is the conclusion. So this reduction is in effect what we call deduct, to take away. And that's the nature of deduction or deductive reasoning, taking away and learning from an idea. The original idea we test is called the null hypothesis. That's box number 1 in blue. In hypothesis testing, you always compare one theory to another, and the second theory should be mutually exclusive from the first one. So since null hypotheses are always structured with an equality or an equal sign, alternatives never have an equal sign. They always have either a greater than or a less than or not equals to. Third aspect of the hypothesis test is once you have 2 competing theories, what you need to do is collect data, and this data should abide by some conditions. Namely, the data should be constructed or gathered from in a random sampling mechanism. The observation should be independent from each other. You shouldn't have too much data. You should have less than 10% of the population, but you also shouldn't have too little data. You should have at least 10 successes and at least 10 failures in the characterization of these in the categorization of your data towards figuring out what percentage of values obey a certain characteristic. The fourth ingredient in the hypothesis test is called the level of significance of the hypothesis test, which is a probability that we preset so that we have a way to measure something called reasonable doubt against the null hypothesis. In other words, at the onset of your investigation of the null hypothesis, you have to figure out what chance do you want to assign to rejecting this theory, regardless of what it is that you observe in the data. So you should be willing and able to have a probability that accounts for the possibility of error, that you might be rejecting something that in the end proves out to be true. And we call that a significance level. That's what the alpha is. So upon having organized those 4 components in a hypothesis test, you combine the data and the statistics from the data with the null hypothesis to form something called a test statistic. And what a test statistic measures is the number of deviations between what you see in the data and what you believe is the case according to the null hypothesis. This test statistic then gets combined with the alternative hypothesis to create something called a p-value. And the p-value is a probability of accepting the null hypothesis given how close the data that you observe is from the null hypothesis. And so you end up with two probabilities, the probability against the null called alpha and the probability in favor called the p-value. So when the probability in favor is bigger or equal, we keep the null hypothesis, otherwise we reject the null. So that's how we ultimately conclude whether a theory that we formulate called a null hypothesis is to be rejected or not rejected. In StatCrunch, all you do to figure that out is stat, proportion statistics, one sample with summary. Okay. And in your notes that I sent you yesterday, I actually solved the chapter 10 questions in exam 4, questions 4 and 5 in the notes, my versions of questions 4 and 5 in the notes. And what we're gonna do right now is we're going to build a new file with lab 10, question 3. Which is about a startup company about to make a new printer, and it decides to gamble by running a commercial during Super Bowl. The company hopes that the name recognition of the company will be worth the high cost of the ads. And the goal of the company is that more than 39% of the public recognize the brand and associate it with the equipment. So that's the goal of the ad campaign. The day after the ad campaign happens on television during the Super Bowl, somebody hired by the company conducts a poll, and the poll asks 406 randomly chosen people and finds that 176 of them know that the company makes printers. So 176 out of 406 is your data about the name recognition that the company earned playing the ads during the Super Bowl. So then the question is, would you recommend that the company continue to advertise during the Super Bowl? And we're to run this test at an alpha at a level of significance of 5%. So let's see how this paragraph translates into the 4 ingredients that we mentioned a hypothesis test should have. So to do that, I'm going to build 4 text boxes. 1, 2, 3, and 4. Okay. So the first box is the null hypothesis. And the second one is going to be the alternative hypothesis. If we look at the first number that appears here, it's not really a number, it's a range of values. It's a range of proportions. It says that the goal of the company is that more than 39% of the public recognize its brand. So that's saying P is greater than 0.39. So that's what that's saying. And that, by definition, has to be the alternative hypothesis, because a null hypothesis will always have an equal sign. So in this case, the null hypothesis cannot be a greater than, it has to be less than or equals, By definition, the null always has inequality in it. Then our data comes next, and we're told that out of 406 people observed, 176 of them said that they recognize the company. So essentially, the number of observations and the number of successes are given in the next paragraph or in the next sentence.
Do you mind showing us where you're typing this, Professor?
Yes, ma'am.
Thank you.
There we go.
All right, perfect. Thank you.
Thanks. And then the alpha, this level of significance of the test, is the 5% that they give you in the last part of the question there. Okay. So as you read the question, you should be basically creating these 4 parts to your deductive thinking process. And what you then do to go through the earlier mentioned step-by-step on hypothesis testing is you go to StatCrunch, you look under proportion statistics, one sample with summary, and then you enter the data. You enter the 176 persons who recognize the printer brand out of the 406 people that are surveyed. And then under perform, you leave the perform button on hypothesis tests. You set the null hypothesis to a proportion that is equal to 0.39. And you leave the alternative to a symbol of greater than as opposed to a symbol of less than or not equal to. And then you click on compute to get the answer or to get the answers. And the answers include a sample proportion, which is calculated by dividing the number of people who identify the brand by all of the people surveyed. That's called the sample proportion. Then it calculates the standard error of the sample proportion. And then it gives you the lower limit to a confidence in, then it gives you the test statistic for the hypothesis test. And then it gives you the p-value for this hypothesis test. So it gives you those 4 things. So those are the answers that you see in StatCrunch. So I'm going to go to StatCrunch and do this. So here's the question. That's part A, equals versus greater than. Part B asks, compute the test statistic. So what I'm going to do to compute the test statistic for this question here is I'm going to go opening StatCrunch. And in StatCrunch, I'm going to go stat, proportion statistics, one sample with summary. Upon clicking on with summary, you get this window where you put in the success count, the observation count, and the null hypothesis, and the alternative hypothesis. And this is really important, this last part. If you're testing equals versus greater than, then definitely do not leave this at less than or not equals, because otherwise the statistics are not going to get computed correctly. So you must have the null correct and the alternative correct. The statement of both theories that are competing against one another in this test is very important. So not only is the data important, but also listing the null and the alternative correctly. Okay. You click on compute. And you get this, you get these results. So I'm copying the results to your notes for today. So again, you start with stat, proportion stats, one sample with summary. Then you enter the number of successes and the number of observations, and you enter the null hypothesis value, and you enter the correct sign for the alternative hypothesis. And then click on compute. And that gives you the sample proportion, the standard error of the model, the test statistic, and the p-value. And the test statistic is directly the question being asked here, the 1.8. That 1.8, and the p-value is the 3.6%. So what are those numbers? What do they mean? What do they tell us? Okay. So the test statistic measures how different or how similar. It measures how many standard deviations apart the null hypothesis is from the data, from the sample proportion in the data. So you got to remember here that the null hypothesis says that 39% of people recognize the product. Recognize the brand. the data says that it's actually 43% who recognize the brand. Where did I get that 43.3%? That came from the sample proportion here. And these two numbers are different by 1.8 standard deviations. What we see from the null hypothesis, from what we believe. Hypothesis testing is basically an exercise in seeing versus believing. So what you see is called the data. This is what you see. And this is what you believe in the hypothesis test. What you believe is the theory with regards to the proportion of people who recognize your brand. And what you want to do at first is compare what you see versus what you believe. And when you do that, what you get is the test statistic. This test statistic here that says 1.8. So 1.8 is the number of deviations that separate what you see from what you believe. And then the p-value is the probability that the null hypothesis is true, given what you see in the data. In other words, is it possible to see 43% of a sample telling you that the brand is recognizable in the group of 406 people, when the reality is that 39% of everyone can recognize the brand? So the p-value is the probability that you see 43.3% of 406 people identifying the brand, while for the population, it is 39% of everyone who can identify the brand. So there is a 3.62% chance the null is true. And we are allowed to doubt the null hypothesis ,5% of the time, because that's what alpha is. So the conclusion is that we have to reject the null, because we have less faith in the null than we have belief in the null. Okay, so notice how we had the alternative hypothesis combined with the test statistic to create the p-value. And then the p-value got compared to the level of significance. And that led us to the conclusion that we needed to reject the null hypothesis. Okay, so the data and the null combine to form the test statistic. The alternative and the test statistic combine to give you a probability that favors the null. And when you compare it to the 5% significance level, it ends up being smaller than 5%. And as a result of that, we end up rejecting the null hypothesis because the p-value was only 0.0326. Much smaller than the 5% of alpha. So when you reject the null, that means that the alternative hypothesis is better than the null. And that means that the percentage of people who recognize the brand is more than 39%. And what that then means is that we should keep advertising in the Super Bowl. So that's how we get the final conclusion to this question. So based on the evidence in this sample here, that sample leads us to conclude that we should keep advertising in the Super Bowl because the poll that we conducted on 406 people told us that in effect more than 39% of everybody who listened to the Super Bowl ad recognizes our brand, and that brand recognition has a value to the company in terms of sales and profitability ultimately. So that's a long question, long problem. So let's go back to the question 3. The test statistic was 1.8. The p-value was 0.0362. 0.0362 is less than 5%. So would you recommend that the company continue to advertise? Yes, because the null hypothesis is rejected, which means that there is sufficient evidence that more than 39% of people recognize the product. Okay. So that question, question 3 of 7, is kind of an important lab question because it has everything, it touches on every aspect of hypothesis testing that's important to the whole process of hypothesis testing. It develops the model for testing by giving you a null and an alternative theory. It then proceeds to take the data and compare it to the null to get a test statistic. You use the test statistic along with the alternative to get the p-value. And then the p-value gets compared to alpha so that you can make your conclusion to either keep advertising or not keep advertising during the Super Bowl. Any questions about this particular lab? I'm going to call this lab Lab 10, question 3.
Yeah, thank you for explaining that so detailed. Like, you don't have to do 6 anymore because it's almost the same thing with this test statistic, but do you mind if we do 7 instead?
Not at all. So 4 is also like 3. You go through the hypothesis and you say the probability, the percentage of something is 74. The alternative is that the percentage has decreased. So this is a less than. And then you find the test statistic by comparing the 66% to the 74% in the data sample. In standard deviation units. And the math is all done by StatCrunch. So all this is, again, stat, proportion statistics, one sample with summary. And then you enter the X value, which is 66% of 1,082 investors. So that's what X equals. N is 1,062.82. And then you just do hypothesis testing. And you put 0.74 for the null value. And you put a less than for the alternative. And then you click on compute. And it gets you the results that you need for problem 4. Then for problem 5, as you were saying, this again is what is the null and what is the alternative. Problem 6 is the same. It's about a professor where you have 10% of students dropping versus less than 10% dropping. This is also on exam 4, so it's on your exam 4 notes. And then over here, you have a problem that goes over and asks you if these conditions are met. the conditions that they're talking about there are the conditions that we talked about earlier on about going from 4 parts to 3 parts to 2 part to 1 part. We said that especially in the case of the data, it's important that these 4 conditions on the data be met. The 4 conditions are that the sample should be random, that the observation should be independent, that you shouldn't have too much data, you should have less than 10% of the population, and you shouldn't have too few data points. You should have at least 10 successes and at least 10 failures. So that's what this problem is asking you to do here. And notice how the survey interviewed 610 people, and 175 of them remember the ad. So that's definitely more than 10 people remembering and more than 10 people not. The sample is random. It says here that it's a random phone survey. And it then says that the 10% condition is met because the survey is of 610 randomly chosen people in a radio station survey. And hopefully the radio station has a reach of millions or hundreds of thousands of people, not just a couple of hundred people, because then you have fewer than 10% of the population. So once you know that the conditions are met, the null is always an equal sign. The alternative here is a company is willing to renew its advertising contract with a local radio station as long as it can be convinced that more than 28%. So this is a more than. And this is 0.28. And this is 0.28. And then to do the test, it's just like it was in problem 6, where you do in problem 5 and 4. You do this stat blah, blah, blah stuff. To calculate the test statistic, you're just gonna do stat proportions. That's one sample with summary. X is the number of people who identify the brand, 175. N is the people surveyed at random, which is 610. The null hypothesis test value is 0.28. And the alternative is a greater than. So if you enter those into the stat crunch, you'll get the test statistic, the p-value, and you can then reach your conclusion. That makes sense?
Yeah, that makes sense. Thank you so much.
You're welcome. So in every one of these problems, you're using StatCrunch to do the math. Don't do the math by hand. It's 20th century. In the 21st century, we let computers do the stuff, do the remedial stuff of multiplying and adding and subtracting. So let me check on the chat to see if we have anything else that people requested about. In chapter 11. So Alan asked for question 5 in the lab, and before that Lorena asked for some quiz questions in quiz 11. So let's move towards those. Okay, let me So the files that I'm using for Word, I sent yesterday via email. And I'm gonna just put them here as well. And hopefully you can open them and download them. So yet another way to get the notes to you all. So now we're moving on to quiz 11. Lorena, I don't know if this is a scrambled quiz, so maybe I'll need your help to find question 7 and 10. So do you remember what question 7 was about, Lorena?
Let me check.
In mine, it was about an audit.
Yeah, it's that one.
Okay. Can you see it on my screen?
Yeah.
Cool. Okay. So in this case, there's an accounting firm, and they're trying to figure out if they should keep their fees the same from one year to the next, or if they should modify their tax fees, their advice fees. Last year, the cost to the firm to do an audit was $720 per audit. So that's last year, $720 per audit. This last year, they want to see if this last year the costs to the firm running an audit have changed or not. And as a result, the firm samples 34 client audit fees. The sample average was $680. And then to this $680, you're going to be giving and taking and giving what we call the margin of error, so that we can reach what's known as a lower limit and what's known as an upper limit for the relevant confidence interval. So a confidence interval is always a low and a high that you create to form an interval that has a very high probability. We call that probability a confidence level. So in this case, we're going to have 99% chance that inside of this interval are the costs of all the audits of this year, even though there were only 34 client audits used in determining this statistic. So we took a sample of all the audits, 34 of them, and we're trying to use how much these 34 audits cost us to infer what the cost was per audit for all the audits. Okay, and that's going to be a function of the number of standard deviations in this context. And in chapter 11, we're talking about not the standard error of a proportion, but the standard error of a mean. And so the margin of error is going to actually be a function of a few statistics that are different than for the world of proportions in chapter 9 and in chapter 10. Okay. So we have to look at chapter 11. at our notes from chapter 11. So I hope you can see the notes from chapter 11. And what makes chapter 11 different from what we have been doing in chapters 9 and 10 is highlighted in red versus the purple color arrows that you see in the slide here. In chapter 11, we're basically following the same pattern of inferences. There are only two things we can do to make inferences. We can think inductively or deductively. When we think inductively, we build confidence intervals. When we think deductively, we think with hypothesis testing. And what we did in chapters 9 and 10 is learn how to use both induction and deduction with respect to proportions from categorical data. While in chapter 11, we're just going to be doing the same two activities, but instead of applying them to proportions from categorical data, we're going to apply them to averages from quantitative variables. That's the only difference. When we do that, what we learn is that there are two different kinds of situations. One situation is when we know the population standard deviation. In those cases, the model that we use to help us identify all these inferences is normal. If, on the other hand, we don't know the population standard deviation and all we have is some evidence of standard deviation from a sample, then we're going to use this new model called the t-distribution in pink. So a t-distribution is similar to a normal model in that it tries to capture the number of standard deviations from the center of the calculation we're estimating. And in the case of means, that model is sometimes no longer normal. It requires more standard deviations from the center. It requires that it be a t-distribution model. So that's what that t means. It means that we're looking at a critical value that is from the t-distribution instead of being from the z or normal distribution. And so the way we calculate the lower and upper limits of our confidence interval is we go to StatCrunch. And we go, instead of proportion statistics, we're no longer going to be doing proportion statistics because we're not doing proportions at all. We're just going to be doing t-statistics in this case because all we know is the sample standard deviation of the model. So we're going to go stat t stats one sample with summary. And in the case of test statistics that follow a t-distribution, what you do is you request a confidence interval, change the level of confidence to whatever you want it to be, enter the sample mean from the data, enter the sample size, and the sample standard deviation. So for that, I need to go back to the test and see that the sample deviation was 75, that the number of clients was 34, and that the average cost of the 34 people in the data are $680. With a plus or minus $75. So you enter the sample mean, the sample standard deviation, the sample size, the level of confidence, and you compute. Okay. So that's what you have to do to calculate the confidence interval. And notice that the result in the confidence interval is a lower limit of $645 and an upper limit of $715. Based on the confidence interval, what do I think of the claim that the average cost has changed? Well, what was the cost before last year? What was the cost before this past year? The cost was 720. Is 720 inside the limit? No, 720 is above. So the interval does not contain the historical average. And that means that the average cost is probably lower because there's no evidence that it's the same or higher. There's evidence, I'm 99% sure that the average cost per audit has gone down for me. And that's all I have to do to solve question 7. Do you have any questions about any of the components that I went through or any of the ingredients that I went through?
No.
Hello?
No, it was
Okay.
I understand.
I hope I'm not going too slow or putting you to sleep with my monotonous voice or anything like that. Okay, so all we're doing is comparing past realities to current data about samples. And because the data come from samples, there's error built into our current data. And we're hoping that the amount of error is not so large as to confuse our conclusions and not enable us to know that the direction of change of the world. And then for question 8, I'm sorry, for question 10, what I have to do is I have to use this data from the 11 yogurts. The 11 yogurts are independent. The randomization condition is met. The 10% condition is met. The nearly normal condition, that I have to determine by opening this in StatCrunch and checking to see if the histogram of the values of the data look normal or not. So I'm going to go and graph a histogram of the data. And it doesn't look bad. It doesn't look not normal. There's very little data. There's only 11 yogurts. So it's hard to say that this is not a normal, that this process that's generating this data isn't approximately normal. But I may also want to do what I did in chapter 3 and compute the mean and the median to see if they're close or equal. And I get that the mean and the median are identical, so this is pretty symmetrical. And as a result of that, I can trust that this is relatively normal in shape and that this data have a very strong chance of having a normal shape. And then how do I find the 95% confidence interval for the average calories in a yogurt? Well, to do that, I go back to the data. And I click on Stat, T-Stats, one sample with data. Pick the data, pick the level of confidence, and then build a 99% confidence interval. In this case, they wanted a 95% confidence interval, my bad. So I just go back and change the option to a 95% confidence interval. So it's about 114 calories, 115 calories to 146 calories is the average number of calories per yogurt. So I use the low end, 115 to 146. And that is my 95% confidence interval estimate for the average number of calories per yogurt, per vanilla yogurt, out of all the brands. So I would say that we can be 95% confident that the confidence interval has the real average per yogurt, per vanilla yogurt, out of all the different yogurts. So question 10 and question 7 are both confidence interval questions. On the other hand, question 9 is a hypothesis test question. So you had a fleet of cars, and the fleet of cars does miles per gallon of 24 versus less than 24. To do the analysis, you used a sample of size 50, and it does look like all the conditions are met for this group of analyzed trips because they were chosen at random. And then you're asked for the p-value and for the comparison between p-value and an alpha and you're done, just like you did in chapter 10. So chapter 11 is kind of like a rehash of chapter 10. You're doing confidence intervals and you're doing hypothesis tests. But they do not have anything to do with proportions anymore. They just have to do with means. They have to do with population means. Any questions? So I have a question from the lab 11, question 5.
Yes.
So here in question 5 of lab 11, you have a store owner, like a 7-Eleven or a convenience store owner, and the owner checks on 25 randomly picked customers, and he finds that the average of those 25 customers, the average age is 32 years old, give or take 10 years of standard deviation. And the owner wants to know if the average age of all customers is 36 versus not 36. So you're testing a hypothesis between equals 36 and not equals 36. And these two numbers here, the 32.08 and the 9.67,
Yeah.
those are your mean and deviation of your sample. So your test statistic is going to be that you see 32.08. You believe that the true number for everybody is 36. And you have to calculate that in units of standard deviation, which is 967 divided by the square root of the sample size.
Okay.
So this thing is a little under 2, and 4 divided by 2 is about -2. So you're going to end up with a test statistic that's about -2. And the p-value for that is going to be roughly 4%, 6%, something like that. Okay. Instead of doing guesswork, I'm going to take the data and I'm going to open it in StatCrunch.
Okay.
And I'm going to go stat, t-stats, one sample with data. I pick the variable. The null is 36. The alternative is not. Compute. There's my test statistic. And there's my p-value. So my test statistic was -2.03. And the p-value is 5.39%. So I go back to my homework. .0539.
Okay.
And then when I compare 5% to 10%, 10% is my probability against the null. So I find that the p-value is less than alpha. So that means that I reject the null. And that means that there's enough evidence to say that my customers on average are not 36, but rather they are different age than 36. So again, it always boils down to what is alpha and what is p-value. Alpha is the probability against the null. P-value is the probability in favor of the null. So when alpha is bigger, the null is rejected. When p-value is bigger, the null is not rejected.
Okay.
It's the same strategy. And notice how it's easier to just take the data and do the procedures. Stat, t-stat, one sample with data. and let the software do the math
Yeah.
instead of having to do the math by hand. So sometimes following the view and example is just a little too time consuming.
Yeah. Thank you so much. That made a lot of sense.
Absolutely. I'm glad it's working out for you guys. It was a tough semester for everybody, and I'm glad that you're, you know, making the best of it. So, I'm gonna take a break and go get some coffee, and then I'll be back at 1:30, guys.
Can you please send us the link for your office hours?
Let me do that right now before I leave, okay?
Thank you very much.
Hey, Professor.
Hello.
When will we know how many points from the extra credit we're gonna get? Because that'll help us like figure out how many of the assignments we need to like get and how many points we need to get.
Just assume that it won't be below 150. So assume 150 or above.
Okay.
I haven't seen anybody who's gotten less than 150. So.
Okay. Thank you.
You're welcome.